In this demo, we present Chiminey software platform. Researchers have been using computing resources such as desktops and supercomputers for running their experiments. But what if they want to run their code on bigger problems? In order to use new resources, researchers are expected to know how to deal with cloud techniques, which itself is a unique challenge. Chiminey platform is designed to enable the user to focus on domain-specific problems and to delegate the software to handle resource and computation management. Researchers are not required to have a deep technical understanding of cloud computing, high-performance computing, fault tolerance, or data management and visualization in order to leverage the benefits provided by Chiminey. Users may interact with Chiminey via a web-based graphical user interface, which you can see now. One of the main challenges is the development of smart connector components of Chiminey. An execution of a smart connector is called a job. After logging in, we see the status of current and previous jobs. Some may be processing, have been completed, or had errors. If we go to the settings section, we can set up general account properties and, which is more interesting, change settings of computation and storage platforms. If we select Create Job in the menu, we will see the job submission page, which has a set of available smart connectors registered in the Chiminey system by now. A smart connector interacts with a cluster or a cloud service on behalf of the user. It sets up the execution environment, creates the virtual machines, configures them for the upcoming simulation and so on, runs a computation, and then transfers the output of the computation to the user's desired location. Now we show how to create a job on example of execution of Monte Carlo simulations, which was a part of one of our case studies to evaluate the Chiminey system. The user does not need to know about how virtual machines are created and destroyed, how a simulation is configured and executed, or how the final output is transferred. Smart connectors vary from each other by the type of the computation to be supported. Chiminey provides a set of APIs to create new and customize existing smart connectors. Now we see the new job being executed. The job will start by creating as many subtasks that are required for the calculation, and then each will create needed cloud resources to carry out the calculation. The execution can be monitored. From the readability point of view, it was a challenge to develop a user interface which is intuitively clear to the research scientist who do not have a deep technical understanding of cloud computing and fault tolerance. When the results of the calculation are produced, they are automatically transferred in the MyTardis data curation system. These results can be represented as 2D or 3D graphs using a plugin developed to provide better readability of the obtained data. The curated datasets are fully accessible and shareable online. An important point here is that we do not restrict our system to be built using a single programming language. Python was chosen as the development language due to its rapid prototyping features, integration with our data curation system, and due to its increasing uptake by researchers as a scientific software development language. However, the domain-specific calculations could be written in any language. The choice of the language depends on the domain and the concrete research task which should be solved. We have evaluated our system with case studies in physics and structural biology, and the domain experts noted the time savings for computing in data management and usability aspects of the system. We believe that Chiminey will have a strong positive impact on the research community because it gives an opportunity to focus on the main research problems and takes upon itself solving of the major parts of the infrastructure problem. Thank you for your attention.